It's a bird. It's a plane. No, it's someone with curls. It's Math Girl. Alright, now we're going to be doing trig proofs. It's not as bad as it sounds. So if you can see this problem right here, basically what we're going to be doing is we're going to be proving that one side is equal to the other side. Okay, that's what we do when we do trig proofs. In geometry, proofs were about proving triangles congruent. In trigonometry, you're proving that one side is equal to the other side. So we're going to prove that this is equal to this. Okay, how do we do this? Number one, you're going to use trig identities. Identities are such that cosecant is equal to 1 over sine, or tangent is equal to sine over cosine, or secant is equal to 1 over cosine. We're going to use identities that we're learning in trig. The next step is I recommend changing everything to sine and cosine. Then use math skills to add, make common denominators, cancel. Okay, step 3 is to try changing only one side first. If that doesn't work, then look ahead because you may need to change the other side too. If you've ever played chess or checkers, you have to think ahead in chess. Doing trig proofs is the same way. You have to ask yourself, if I do this step, what's going to happen? Or if I try this other step, what's going to happen? The main thing, the last thing to say is that there are several ways to do these proofs. There's no clear-cut steps to follow. Okay, there are several different ways to do it. So you might come up with a way to prove that this is equal to this that's different than the book or different from the person sitting next to you, and that's okay. So we're going to look at 8b5. So the very first thing that I recommend is to change everything to sine and cosine. That's usually the first step to try. Okay, so here we have cosecant squared theta over secant squared theta is equal to cotangent squared. So I'm going to change everything into sine and cosine. Cosecant, that is the same thing as 1 over sine. So, and that was cosecant squared, so this needs to be a sine squared. So 1 over sine squared. Now let's change secant. Secant is the same thing as 1 over cosine squared. What I'm just going to do is first I'm going to work on changing the left-hand side. I'm not going to change the right-hand side yet, but what I do is just write your equal sign, and I can just rewrite this. Because when you're done, you want one side to equal the other side so that you've proved it. Okay? Now I have a fraction divided by a fraction. How do you divide fractions? You flip and multiply. Okay? So flipping and multiply, this becomes 1 over, you flip the second one. That becomes sine squared times cosine squared theta over 1. I took this one, flipped it, and multiplied. Okay? So now the left-hand side becomes cosine squared theta all over sine squared theta. What is cosine over sine? Okay, from the trig identities, cosine over sine is equal to cotangent. And since they're both a square, then cosine squared over sine squared is equal to cotangent squared. Because this is the same thing as saying cosine times cosine all over sine times sine. Well, cosine over sine is a cotangent. Cosine over sine is a cotangent. Cotangent times cotangent is cotangent squared. So I'm just showing you this step to prove that when these are squared, then you still have a squared there. So basically then that is cotangent squared is equal to cotangent squared. I don't generally box anything on my trig proofs because your whole problem is the answer. Everything that you work at is the answer. But the goal is to get down to where you have one side is equal to another side. And that proves that the left side equals the right side. These kinds of problems just take practice, and they're not all necessarily exactly alike. Okay, so let's go down to 8d7. And again, these just take practice. So we have secant, this Greek letter is beta. Secant beta times cosine squared beta. When you have trig functions right next to each other, that implies multiplication, is equal to sine of 90 minus beta. What do you recognize this as? this is a cofunction, okay? So our cofunctions, we said that cosine of beta, or we could use theta, is the same as sine of 90 minus the other angle. So I can replace this whole thing, sine of 90 minus the other angle, I can replace this with cosine. So on the right hand side, I'm going to replace this whole thing with cosine because sine of 90 minus beta equals cosine of beta. That was from our cofunctions. Now going to the left hand side, my first goal that I always do is to change everything into sine and cosine. Okay, so I'm going to change secant into sine or cosine. Secant is 1 over cosine beta times, because this means multiplied, cosine squared beta. I can turn that into a fraction by putting it over 1. This is just multiplying fractions. What happens to our cosines? One of those will cancel. So one of those cancels with that. I usually just mark out my exponent. So then all I have left is cosine beta is equal to cosine beta, and I just proved that the left side is equal to the right side. Alright, now we're looking at 8D5. Some proof problems are longer than others, some are shorter than others. So here we have this. I'm going to work with the left side first. And again, I haven't worked this out ahead of time because I want to work it as, I want to be thinking about it as I'm working it so you can hear how I think about working this, okay? So I'm just going to start changing the left side, and again, the general rule is usually to change everything into sine and cosine, okay? So cosecant is the same thing as 1 over sine theta plus secant is 1 over cosine theta all over cosecant is 1 over sine theta plus minus secant is 1 over cosine theta equals. I'm not going to rewrite that because I'm not going to change the right hand side, so I'm just going to leave it there for now. Okay, let's look at the very top. What are we doing? We're adding fractions. What do you have to do when you add fractions? Make a common denominator. So our common denominator will be sine times cosine. Sine times cosine. So for this fraction, we need to multiply a cosine to it. Whatever I do the denominator, I have to do the numerator. For this fraction, I need to multiply a sine to it. Okay, let me just do that first. I'll come down here to the bottom in a minute. So to rewrite this, my new fraction would be cosine theta all over cosine theta times sine theta. That's this whole new fraction right here after making a common denominator. Plus this new fraction, which would be sine theta all over cosine theta sine theta. So I now have a common denominator. Okay, now let's do the bottom. Okay, subtracting fractions. I have to have a common denominator. Multiplying these two together to get my common denominator, which means this one needs to have a cosine multiplied to it. This one needs to have a sine multiplied to it. It's the same process of making common denominators, except we're using trig functions. So this new fraction will now be cosine theta all over cosine theta sine theta minus, now this new fraction, sine theta over cosine theta sine theta. Okay, I haven't changed anything on the right hand side. Okay, now let's look at the top. Now that I have a common denominator, I can combine my numerator. I can't add cosine to sine, but I just write it as cosine theta plus sine theta all over my common denominator, which was cosine theta sine theta. Now in the bottom, so there's my big long fraction. Combining our fractions, I would say cosine theta minus sine theta all over your common denominator. Now that we have simplified the top and we have simplified the bottom, we have a fraction divided by a fraction. How do we divide fractions? We flip the second and multiply. So, rewriting the first one, and then flipping the second one and multiplying. I'm multiplying, I'm going to flip this one to where this now becomes the numerator, and my cosine theta minus sine theta becomes my denominator. Okay, what happens to my cosine theta, sine theta? Those cancel. That all cancels, and I'm left with cosine theta plus sine theta all over cosine theta minus sine theta. When you get down to where you just have cosines and sines and you still don't match your right hand side, that's when I would go and change the right hand side. Okay, so I'm going to stop there because I've simplified. I changed everything to sine and cosine, made common denominators, I simplified the most that I could, and I'm still ended up with cosines and sines, and I don't match the right hand side. Now I'm going to go to the right hand side and change it to see if I can get the right hand side to match this. Okay, so going back to the right hand side, let's change everything to sine and cosine. So this would be 1 plus tangent is sine over cosine all over, and then 1 minus tangent is sine over cosine. These ones, you can make any number of fraction by putting it over 1. So this 1 is like saying 1 over 1. Same with this one, 1 over 1. I'm adding fractions. What do I have to do to add fractions? I have to have a common denominator. This one needs to have a denominator of cosine. So therefore I need to multiply this fraction by a cosine. I'm just going to write it tiny right there, cosine. Same here. This one needs a denominator of cosine, so I need to multiply a cosine to it. Okay, so then down here, my new fractions, basically you had cosine over cosine plus sine theta over cosine theta. This was just my 1. I changed my 1 into cosine over cosine, which that makes sense. Anything divided by itself is 1. Okay, in the bottom, when I made common denominator, I had cosine over cosine minus sine theta over cosine theta. Okay, now let's go back to the top. I now have a common denominator, so I can combine my fraction to say cosine theta plus sine theta all over my common denominator of cosine theta, and in the bottom, same thing. I have a common denominator, so I can combine my fraction to say cosine theta minus sine theta all over my common denominator. I've simplified the top, I've simplified the bottom. Now I have a fraction divided by a fraction, so I flip and multiply. So here's my top fraction. So I flip the bottom fraction and multiply. So that now becomes a numerator. And that becomes a denominator. What happens to these cosines? You can cancel when you're multiplying. You cannot cancel when you're adding. These two things are married and joined by this addition sign. These two things are married and joined by the subtraction sign. You cannot cancel those. So now what you have left is cosine theta plus sine theta all over cosine theta minus sine theta. And now we're down to where the left side equals the right side, and you can stop. Okay? So anytime you're doing trig proofs, the main thing is you're trying to get down to where you get the left side is equal to the right side. Both of these might be completely different than in the original problem, but the goal is just to get to the point that you have proved the left side equals the right side, and I have done that. So I have proved that the very original problem was also equal.